Picture this, a bustling city suspended in the void of space, its lights flickering against the endless black, where people live, work, and thrive far above the Earth. This isn't science fiction, it's the future we're racing toward. What will it take to build these orbital cities, and how will humanity adapt to life among the stars? These questions aren't just fascinating, they're essential to understanding where we're headed as a species. In this video, we'll dive into 30 in-depth predictions about the future of space habitats and orbital cities, from modular designs that grow with us to advanced ecosystems that keep us alive in the harshest environments. Whether it's artificial gravity or the rise of space tourism, each prediction offers a glimpse into a future that's closer than you might think. So, are you ready to explore what life beyond Earth could really look like? Let's take this journey together and uncover the possibilities that await us in the final frontier. Now, let's zoom in on the first of our 30 predictions, modular space habitats that expand over time. Imagine a space habitat not as a single, static structure, but as a living, breathing entity capable of growing and adapting as its population increases. This is the future of space living, and modular construction is the key. Modular habitats are designed to be built in pieces or modules which can be added, removed, or reconfigured as needed. Think of it like building with Lego blocks. Each module serves a specific function, whether it's living quarters, laboratories, or green spaces, and they can be stacked, connected, or expanded based on demand. This flexibility is crucial for sustainable living in space, where resources are limited and every square inch matters. The technology behind this is already in use today, with the International Space Station serving as a prime example. While it's relatively small compared to what we envision for future habitats, its modular design has proven that this approach works. Looking ahead, we could see the International Space Station evolve into something much larger, a sprawling orbital city made up of interconnected modules, each contributing to a self-sustaining ecosystem. This isn't just about scaling up, it's about creating habitats that can adapt to the needs of their inhabitants, ensuring that life in space is not just possible but comfortable and thriving. By embracing modularity, we're laying the foundation for a future where humanity can grow and flourish among the stars. Now, let's take a closer look at the second prediction, self-sustaining closed-loop ecosystems. Picture a space habitat where every breath of air, every drop of water, and every bit of waste is meticulously recycled and reused. This is the essence of a closed-loop ecosystem, a system designed to mimic Earth's natural cycles but within the confines of space. In these environments, nothing goes to waste. Air is purified using advanced filtration systems, water is reclaimed through innovative recycling technologies, and organic waste is transformed back into nutrients to grow food. This level of sustainability is not just a luxury, it's a necessity for long-term space habitation, where resupply missions from Earth are impractical and resources are finite. Advanced biotechnologies play a crucial role here, from genetically engineered plants that thrive in zero gravity to microbial systems that break down waste efficiently. These technologies are the backbone of closed-loop ecosystems, ensuring that life in space can continue indefinitely without external support. Imagine a habitat where every resource is part of a continuous cycle, creating a self-sustaining environment that supports both human life and the ecosystems around it. By mastering closed-loop systems, we're not just solving the challenges of living in space, we're paving the way for a future where humanity can thrive far beyond the confines of Earth. Shifting our focus to the next groundbreaking idea, let's explore the concept of artificial gravity through rotating structures. Imagine living in a space habitat where you can walk, run, and move just as you would on Earth without the disorienting effects of zero gravity. This is made possible through rotating habitats which use centrifugal force to simulate gravity. As these structures spin, the outward force mimics the pull of gravity, allowing inhabitants to experience a sense of weight. This is crucial for long-term space habitation, as prolonged exposure to zero gravity can lead to serious health issues such as muscle atrophy, bone density loss, and cardiovascular problems. Engineering these rotating habitats, however, presents significant challenges. Designing structures large enough to minimize the Coriolis effect, a phenomenon that can cause dizziness and nausea at smaller scales, requires innovative materials and precise construction. One of the most promising designs is the O'Neill cylinder, a massive cylindrical habitat that rotates to create Earth-like gravity along its inner surface. These cylinders could house entire communities, complete with living spaces, green areas, and even simulated weather patterns. While the technology to build such structures is still in development, advancements in materials science and robotics are bringing us closer to making these designs a reality. By solving the puzzle of artificial gravity, we're not just improving the quality of life in space, we're enabling humanity to live and thrive in orbital cities for generations to come. Now let's turn our attention to the next exciting possibility: orbital cities as economic hubs. Picture a bustling metropolis floating in space, not just as a place to live but as a thriving center for commerce, research, and manufacturing. Orbital cities have the potential to revolutionize global economies by unlocking opportunities that are impossible on Earth. One of the most promising economic drivers is asteroid mining. Asteroids are rich in rare metals and minerals like platinum, gold, and cobalt, resources that are increasingly scarce on our planet. Mining these space rocks could supply industries on Earth and in space, creating a new frontier of wealth and innovation. Another game-changing advantage of orbital cities is microgravity production. In the absence of Earth's gravity, materials can be manufactured with unprecedented precision and purity. Think of advanced alloys, flawless crystals for electronics, and even biological materials like artificial organs. These products, which are difficult or impossible to create on Earth, could become staples of a booming space economy. Additionally, orbital cities could serve as research hubs, offering scientists and engineers the chance to conduct experiments in a unique environment. The economic ripple effects of these activities could be enormous, creating new industries, jobs, and markets. By transforming orbital cities into economic powerhouses, we're not just expanding humanity's presence in space, we're reshaping the very foundations of global commerce and innovation. Now, let's shift our focus to an exciting development that's bringing us closer to life among the stars: space tourism. What started as a dream for a privileged few is quickly becoming a reality, thanks to the efforts of pioneering companies like SpaceX and Blue Origin. These commercial space ventures are not only making space travel more accessible, but are also laying the groundwork for permanent orbital cities. Space tourism is more than just a thrilling adventure, it's a stepping stone toward broader habitation efforts. As more people experience space firsthand, the demand for extended stays and even permanent living arrangements in orbit is likely to grow. Imagine tourists spending weeks or months in space hotels, gradually adapting to life beyond Earth. This transition from short trips to long-term stays could spark the development of larger, more sophisticated habitats designed for permanent residence. Companies like SpaceX and Blue Origin are already working on technologies that make extended space travel feasible, from advanced life support systems to reusable spacecraft. Their innovations could eventually scale up to support entire communities living in orbit. Space tourism also has the potential to drive down the cost of space travel. As more people book flights, economies of scale could make it cheaper to launch spacecraft, build habitats, and transport supplies to orbital cities. This financial accessibility is crucial for turning the dream of orbital living into a reality. Beyond the economic benefits, space tourism fosters public interest and support for space exploration. When people experience the wonders of space for themselves, they're more likely to advocate for investment in space habitats and infrastructure. In this way, space tourism isn't just a gateway to orbital living, it's a catalyst for humanity's future in space. Moving forward, let's explore a critical challenge that must be addressed for humanity to thrive in space: advanced radiation shielding technologies. Living in space exposes humans to harmful cosmic radiation, which poses serious health risks over time. Without effective protection, long-term habitation in orbital cities would be impossible. This is why developing innovative shielding materials and technologies is essential for the future of space living. Scientists and engineers are working on solutions that could block or reduce radiation exposure, such as advanced polymers, hydrogen-rich materials, and even magnetic fields. These innovations aim to create barriers that absorb or deflect radiation, keeping inhabitants safe. One promising approach involves incorporating lightweight, high-performance materials into the structure of space habitats. These materials not only provide radiation protection but also minimize the additional weight that would otherwise make construction and launch more challenging. Another groundbreaking idea is the use of electromagnetic shielding, which could generate protective fields around habitats similar to Earth's magnetosphere. While this technology is still in its early stages, it has the potential to revolutionize how we safeguard space residents. Beyond physical shielding, researchers are exploring biological solutions, such as gene therapies or pharmaceuticals that could enhance the human body's ability to repair radiation damage. Combined with advanced materials, these approaches could provide comprehensive protection for those living in orbit. The development of effective radiation shielding isn't just a technical hurdle, it's a moral imperative. Ensuring the safety and well-being of space inhabitants is crucial for the long-term success of orbital cities. As we continue to push the boundaries of space exploration, innovations in radiation protection will play a pivotal role in making life beyond Earth not only possible but sustainable. Now, let's turn our attention to another fascinating aspect of life in space: vertical farming in zero gravity. Feeding a growing population in orbital cities will require innovative solutions, and vertical farming offers a promising answer. In the absence of gravity, traditional farming methods won't work, but vertical farming techniques can be adapted to thrive in space environments. These systems stack crops in layers, maximizing space efficiency while using minimal resources. Hydroponics, which grows plants in nutrient-rich water instead of soil, will play a key role. Since gravity isn't needed to distribute water and nutrients, hydroponics is perfectly suited for zero-gravity conditions. Another method, aeroponics, takes this a step further by misting plant roots with a nutrient solution, using even less water while promoting rapid growth. Genetically modified crops will also be essential, as they can be engineered to grow faster, require less water, and withstand the unique challenges of space, such as lower light levels or higher radiation exposure. Together, these technologies will ensure a steady and reliable food supply for space habitats. Beyond practicality, vertical farming could also enhance the quality of life for space residents. Imagine orbital cities filled with lush greenery, providing not just sustenance but also a sense of connection to nature. While the challenges of farming in space are significant, the potential rewards are immense. Vertical farming could transform how we think about food production, proving that even in the most unconventional environments, humanity has the ingenuity to thrive. As we look to the future, these agricultural innovations will be just as critical as any technological breakthrough in making orbital cities a reality. Next, let's explore how renewable energy could power these habitats in ways we've never imagined. Now, let's shift our focus to how space habitats will harness the boundless energy of the sun. Solar satellites hold incredible potential to provide abundant, renewable power for orbital cities. Unlike on Earth, where weather, atmosphere, and nighttime limit solar energy capture, space offers uninterrupted sunlight. Solar satellites can be positioned in orbit to continuously absorb solar energy, free from these constraints. These satellites would use advanced photovoltaic technology to convert sunlight into electricity far more efficiently than ground-based solar panels. Once captured, the energy could be transmitted to space habitats using wireless methods like microwaves or lasers, ensuring a steady and reliable power supply. This system would not only meet the energy needs of orbital cities, but also reduce reliance on finite resources. Imagine a network of solar satellites working seamlessly to power everything from life support systems to manufacturing facilities in space. This innovation could pave the way for sustainable living beyond Earth, offering a clean and virtually limitless energy source. As we look ahead, solar satellites could revolutionize how we generate and distribute energy, proving that the future of power lies among the stars. Next, we'll explore how artificial intelligence will take center stage in managing life in space habitats. Now, let's step into the realm of artificial intelligence and its pivotal role in shaping life within space habitats. In these futuristic environments, artificial intelligence will act as the central nervous system, managing every aspect of daily operations. From regulating life support systems to overseeing maintenance tasks, artificial intelligence will ensure that orbital cities run smoothly and efficiently. Imagine a habitat where the air quality, temperature, and humidity are constantly monitored and adjusted by intelligent systems, creating a comfortable and safe environment for residents. Artificial intelligence will also handle complex tasks like managing energy distribution, controlling waste recycling processes, and even predicting and preventing equipment failures before they occur. This level of automation will not only enhance safety but also free up human residents to focus on more creative and exploratory endeavors. Furthermore, artificial intelligence will be integrated into personal devices, providing real-time assistance with everything from navigation to health monitoring. It will act as a constant companion, offering solutions to problems and ensuring that life in space is as seamless as possible. The use of artificial intelligence in space habitats will set a new standard for efficiency and reliability, making it an indispensable part of our journey into the cosmos. Looking ahead, artificial intelligence will not just support life in space but redefine it, creating a future where technology and humanity work hand in hand. Next, we'll examine how orbital cities could become safe havens for those affected by climate change on Earth. Now, shifting our focus to a pressing global issue, let's explore how orbital cities could become lifelines for those displaced by climate change. As Earth grapples with rising sea levels, extreme weather, and dwindling resources, orbital cities could offer a sustainable alternative for people seeking refuge. These habitats, designed with advanced technologies for self-sufficiency, could provide shelter, clean water, and nourishment for millions of climate refugees. However, the idea of relocating populations to space raises significant ethical questions. Who would have access to these cities? How would we prioritize who gets to go? These decisions would require careful consideration to avoid deepening existing inequalities. Additionally, the logistical challenges of transporting large numbers of people to space are immense. Developing reliable and affordable space transportation systems would be essential, as would ensuring that orbital cities are equipped to handle the influx of new residents. Despite these hurdles, the potential benefits are undeniable. Orbital cities could not only protect vulnerable populations but also serve as a model for sustainable living, inspiring efforts to preserve Earth's environment. As we look to the stars for solutions, it's crucial to address these ethical and logistical complexities to create a future where space truly becomes a haven for all. Next, we'll delve into the transformative role of three-dimensional printing in building and expanding these orbital cities. Now, turning our attention to a groundbreaking innovation, let's explore how three-dimensional printing will revolutionize the construction of space habitats and orbital cities. Imagine being able to build entire structures in space using materials sourced from asteroids or the Moon, without the need to transport heavy components from Earth. This is where three-dimensional printing comes in. This technology allows us to create complex structures layer by layer, using materials that are readily available in space. By leveraging three-dimensional printing, we can drastically reduce the costs and logistical challenges of launching construction materials from Earth. Instead of sending prefabricated modules, we can send raw materials or even use resources found in space, such as lunar regolith or metals from asteroids. This approach not only cuts down on expenses but also speeds up the construction process, enabling orbital cities to expand rapidly to meet growing demands. One of the most exciting possibilities is the ability to print habitats and infrastructure on demand, tailored to the specific needs of space residents. For example, three-dimensional printers could create living quarters, storage facilities, or even research labs in a matter of days or weeks. This flexibility is crucial for adapting to unforeseen challenges or opportunities in space. Moreover, three-dimensional printing opens the door to innovative designs that are difficult or impossible to achieve with traditional construction methods. Imagine habitats with intricate, lightweight structures that optimize space and resources, while also providing strength and durability. As we look to the future, three-dimensional printing will play a pivotal role in making orbital cities a reality, transforming the way we build and live in space. Next, we'll dive into the unique forms of entertainment and leisure activities that will emerge in these futuristic orbital cities. Moving forward, let's shift our focus to a thrilling aspect of life in orbital cities: entertainment and leisure activities. Imagine stepping into a world where gravity no longer limits creativity, giving birth to entirely new forms of recreation. One of the most exciting possibilities is zero-gravity sports. Picture athletes flying through the air, performing acrobatic maneuvers that would be impossible on Earth. Games like zero-gravity basketball or soccer could redefine competition, blending physical skill with strategic movement in 3 dimensions. These sports wouldn't just be for fun, they'd also help residents stay active and healthy in an environment where traditional exercise is challenging. But it's not just sports that will evolve. Virtual reality will play a massive role in shaping entertainment in space. With advanced virtual reality systems, residents could explore immersive worlds, attend concerts, or even visit a virtual Earth, all from the comfort of their orbital home. This technology will be especially valuable for combating the isolation that can come with living far from Earth, offering a sense of connection and adventure. Leisure activities will also extend to unique experiences like zero-gravity art, where artists can create floating sculptures or choreograph dances that defy gravity. Even everyday activities like dining could become an event, with meals designed to be enjoyed in a weightless environment. These innovations in entertainment and leisure will not only enhance the quality of life for space residents, but also foster a sense of community and joy in an otherwise challenging environment. As we continue to envision the future of orbital cities, it's clear that entertainment will be a vital part of making life in space not just bearable, but truly extraordinary. Next, we'll explore how these cities will serve as launchpads for humanity's next great adventures in deep space exploration. Now, let's consider how orbital cities could become the ultimate launchpads for humanity's journey into the cosmos. Picture these cities not just as homes in space, but as gateways to the stars. One of their most profound roles will be serving as staging points for missions to the Moon, Mars, and even farther destinations. Launching from orbit offers a significant advantage compared to launching from Earth. Escaping Earth's gravity requires an enormous amount of energy and fuel, but starting a mission from an orbital city eliminates this hurdle. Spacecraft could be assembled and launched from these cities using far less energy and resources, making deep space exploration more efficient and sustainable. Orbital cities could also act as refueling stations. Imagine spacecraft stopping to replenish their supplies or repair systems before venturing deeper into the solar system. This would enable longer missions and reduce the risks associated with traveling vast distances. Additionally, these cities could host advanced research facilities where scientists and engineers develop new technologies and test equipment in the unique conditions of space. This would accelerate the pace of innovation, making missions to distant planets and moons more feasible. Moreover, orbital cities could serve as training grounds for astronauts. Living and working in space prepares crews for the challenges of long-duration missions, helping them adapt to the physical and psychological demands of deep space travel. With orbital cities as hubs, humanity's exploration of the solar system could expand rapidly, opening up new possibilities for discovery and settlement. As we look to the stars, these cities will be the stepping stones that take us farther than we've ever gone before. Next, we'll dive into how space habitats could replicate Earth's climate, offering residents a sense of familiarity in the vastness of space. Shifting our focus to comfort and familiarity, let's explore how space habitats could recreate Earth-like climates, offering residents a sense of home in the vastness of space. Imagine stepping into a habitat where the air feels just right, the temperature is perfect, and even the humidity mimics a pleasant spring day. This isn't just about comfort, it's about creating environments that support both physical and mental well-being for those living far from Earth. Achieving this level of climate control in space requires advanced technologies. Temperature regulation systems would need to maintain consistent warmth, while humidity controls would replicate the moisture levels found in Earth's most habitable regions. Water vaporization and condensation systems could mimic rainfall, and air circulation technology would ensure fresh, breathable air at all times. These systems would work together to create a stable, Earth-like atmosphere within the habitat. But why go to such lengths to replicate Earth's climate? Beyond the practical benefits, there's a psychological aspect to consider. Living in space can be isolating, and the unfamiliarity of a foreign environment can take a toll on mental health. By recreating Earth's climate, space habitats can provide a sense of normalcy and comfort, helping inhabitants feel more grounded and connected to their home planet. Imagine looking out a window to see a simulated rainstorm or feeling a gentle breeze. These small touches could make life in space feel less alien and more like home. This focus on Earth-like climates isn't just about nostalgia, it's a necessity for long-term habitation. As we prepare for a future where humans live and thrive in space, creating environments that feel familiar and supportive will be key to ensuring the well-being of residents. Next, we'll uncover how orbital cities could become epicenters for education and research, offering unparalleled opportunities for discovery and innovation. As we look ahead, another transformative aspect of orbital cities will be their role as hubs for education and research. Imagine a place where students and scientists can conduct experiments in microgravity, study the stars without atmospheric interference, and develop cutting-edge space engineering solutions. Orbital cities will provide unparalleled environments for innovation, free from many of the limitations faced on Earth. One of the most exciting possibilities is the study of microgravity. In space, researchers can explore phenomena that are impossible to observe on Earth, such as how fluids behave or how materials form in the absence of gravity. These insights could lead to breakthroughs in fields like medicine, materials science, and manufacturing. For example, scientists could grow perfect crystals for advanced electronics or develop new drugs that are more effective due to insights gained in microgravity. Astronomy will also benefit immensely from space-based research. Orbital cities positioned above Earth's atmosphere will offer telescopes and observatories a clear view of the cosmos. This could lead to discoveries about distant galaxies, exoplanets, and the origins of the universe itself. By eliminating atmospheric distortion, space-based observatories could capture images and data with unprecedented clarity, opening up new frontiers in our understanding of the universe. Beyond these scientific pursuits, orbital cities will become training grounds for the next generation of space engineers and explorers. Universities and research institutions could establish campuses in space, offering hands-on experience in designing and maintaining habitats, spacecraft, and other technologies essential for living beyond Earth. This immersive learning environment will prepare students to tackle the challenges of space habitation and exploration, fostering a new era of innovation. The potential for groundbreaking discoveries in orbital cities is immense. By creating dedicated spaces for education and research, we can accelerate progress in science and technology, pushing the boundaries of what humanity can achieve. Next, we'll delve into the development of legal frameworks that will govern life in space, ensuring these cities operate smoothly and equitably. As we venture into the realm of space law and governance, it's clear that orbital cities will require entirely new frameworks to ensure their smooth operation. Unlike anything we've seen on Earth, these legal systems will need to address unique challenges, from property rights in the void of space to defining citizenship for those born or residing in orbital habitats. The absence of national borders in space will necessitate unprecedented levels of international cooperation as nations and private entities work together to establish fair and functional rules. Property rights, for instance, will be a cornerstone of space law. With the rise of asteroid mining, lunar colonies, and orbital cities, questions about who owns what in space will become critical. Current treaties like the Outer Space Treaty of 1967 declare that space belongs to all humanity, but as commercial activities grow, more detailed regulations will be needed. Legal frameworks will have to balance the interests of private companies, governments, and the global community to ensure equitable access and prevent conflicts. Citizenship and governance will also present fascinating dilemmas. Will residents of an orbital city be tied to their nation of origin, or will they develop their own forms of governance? Establishing clear rules around citizenship, voting rights, and legal jurisdiction will be essential to maintaining order and fairness. These decisions will shape the social and political fabric of space communities, influencing how they grow and interact with Earth-based systems. International cooperation will be key to the success of space law. Orbital cities will likely involve collaboration between multiple countries and corporations, requiring treaties and agreements that go beyond current models. Organizations like the United Nations or new space-focused bodies may play a pivotal role in mediating disputes, setting standards, and ensuring that space remains a shared resource for all humanity. The development of space law and governance will not only define life in orbital cities, but also set a precedent for humanity's future in space. Next, we'll explore how these habitats will be designed to support families and communities over multiple generations, creating a lasting legacy in the stars. As we move forward into the realm of multi-generational living, the design of space habitats will need to prioritize more than just survival. It will need to foster thriving communities. Orbital cities will be more than temporary outposts. They will become permanent homes for families, creating a legacy that stretches across generations. This shift will require careful planning to ensure that these habitats are not only functional but also nurturing environments for long-term growth. One of the key considerations will be designing spaces that cater to all stages of life. From play areas for children to workspaces for adults and relaxation zones for the elderly, these habitats will need to accommodate diverse needs. Architects and engineers will have to think beyond the basics of life support systems, integrating elements that promote mental and emotional well-being. Green spaces, communal areas, and recreational facilities will become essential features, helping residents maintain a sense of normalcy and connection in an otherwise alien environment. Social dynamics will also play a crucial role in shaping life in orbital cities. Over multiple generations, communities will develop their own unique cultures, traditions, and identities. This evolution will be influenced by the challenges and opportunities of living in space. For example, the isolation from Earth might lead to the creation of new forms of art, music, and storytelling that reflect the experiences of space dwellers. At the same time, maintaining a connection to Earth's cultural heritage will be important to provide a sense of continuity and belonging. Family structures and relationships will also take on new dimensions in space. Living in close quarters for extended periods will require strong interpersonal skills and effective conflict resolution. Space habitats will need to provide resources for counseling, education, and community building to ensure that families and neighbors can coexist harmoniously. Additionally, the concept of extended families or communal living might become more prevalent as shared responsibilities and mutual support become vital for survival and thriving. Education will be another cornerstone of multi-generational living. Children born in space will need access to high-quality schooling that prepares them for both the technical demands of life in orbit and the broader responsibilities of being part of a spacefaring society. This education will likely include a mix of traditional subjects and specialized training in areas like space engineering, biology, and environmental management. The psychological impact of long-term space habitation cannot be overlooked. Living in an environment that lacks natural sunlight, open skies, and familiar landscapes could take a toll on mental health. To address this, habitats might incorporate advanced technologies like virtual reality to simulate Earth-like environments or create immersive experiences that provide a sense of escape and relaxation. Mental health support systems will also be crucial to help residents cope with the unique stresses of living in space. Designing for multi-generational living will also mean planning for growth and change. As populations increase, habitats will need to expand and adapt without compromising safety or quality of life. This could involve modular designs that allow for gradual expansion or the creation of entirely new habitats connected by transportation networks. Flexibility and scalability will be key to ensuring that these cities can evolve alongside their residents. The cultural implications of multi-generational space living are profound. Over time, space communities will develop their own identities, potentially leading to a new branch of human civilization. This raises questions about how these communities will interact with Earth and whether they will eventually seek greater autonomy or even independence. The choices made today in designing these habitats will shape the future of humanity in ways we can only begin to imagine. As we look toward the next frontier, the design of space habitats for multi-generational living represents not just a technical challenge but a deeply human one. Next, we'll explore how robotics will play a vital role in maintaining these habitats, ensuring they remain safe and functional for generations to come. As we continue our journey into the future of space habitats, it's clear that robotics will play an indispensable role in maintaining these complex environments. In the demanding conditions of space, robots will take on tasks that are too dangerous, repetitive, or intricate for humans, ensuring that habitats remain safe and functional for generations to come. From routine repairs to intricate cleaning operations, robots will become the unsung heroes of orbital cities. One of the most critical areas where robots will excel is in the maintenance of life support systems. These systems are the backbone of any space habitat, and their failure could have catastrophic consequences. Robots, equipped with advanced sensors and artificial intelligence, will monitor these systems around the clock, detecting and addressing issues before they escalate. Imagine a robot that can navigate the tight corridors of a habitat, identifying a leak in the oxygen supply and sealing it within minutes. Tasks like these will be vital for long-term survival. Cleaning, while seemingly mundane, will also be a significant challenge in space. dust, debris, and microgravity can create unique cleaning hurdles that robots are well suited to handle. Specialized cleaning robots designed to operate in zero-gravity environments will keep habitats hygienic and safe. These robots might use electrostatic tools or vacuum systems to collect particles that would otherwise float freely, ensuring that living spaces remain comfortable and free of contaminants. Repairs and construction will be another major area where robots will shine. Building and maintaining a space habitat is no small feat, and human labor alone would be insufficient to meet the demand. Robotic arms and autonomous construction drones will perform tasks like welding, bolting, and assembling components with precision and efficiency. These robots will also be capable of working in hazardous environments, such as exterior repairs outside the habitat, where radiation and meteoroid risks are high. Advancements in artificial intelligence and machine learning will be the driving force behind these robotic capabilities. Robots will not only follow pre-programmed instructions, but also learn from their experiences, adapting to new challenges and optimizing their performance over time. For example, a repair robot might learn the most efficient way to replace a damaged panel or develop new techniques for troubleshooting malfunctioning systems. This adaptability will make them invaluable partners in the ongoing maintenance of space habitats. The integration of robotics into space habitat maintenance will also reshape human roles. While robots handle the bulk of physical labor, humans will focus on overseeing operations, programming, and decision-making. This shift will require a workforce skilled in robotics, engineering, and artificial intelligence, creating new opportunities for education and career development in space. Humans and robots will work together as a cohesive team, each complementing the other's strengths. The psychological impact of relying on robots cannot be overlooked. While robots will take on many tasks, human interaction and creativity will remain essential for maintaining morale and innovation in space communities. Robots might handle the drudgery, but humans will continue to drive the cultural and intellectual growth of these habitats, ensuring that life in space remains vibrant and fulfilling. As we look to the future, the role of robotics in space habitat maintenance highlights the importance of collaboration between humans and machines. These technologies will not only ensure the safety and functionality of our orbital cities, but also pave the way for humanity to thrive in the vast expanse of space. Next, we'll explore how orbital cities will become cultural melting pots, bringing together diverse communities and fostering new forms of expression and connection. As we shift our focus to the social fabric of these futuristic environments, orbital cities will emerge as vibrant cultural melting pots, bringing together people from every corner of the globe. In the unique setting of space, individuals from diverse backgrounds, traditions, and worldviews will converge, creating a rich tapestry of human experience. This blending of cultures will not only enrich life in space, but also give rise to entirely new forms of expression and connection. The microgravity environment and the shared challenges of space living will foster a sense of unity among inhabitants, while also encouraging the exchange of ideas and traditions. Picture a city where a chef from Japan collaborates with a farmer from Kenya to create innovative zero-gravity cuisine, or where artists from different continents combine their techniques to produce groundbreaking visual and performing arts. These interactions will spark creativity and innovation, giving birth to new cultural practices that are uniquely shaped by the realities of life beyond Earth. Language will also evolve in these orbital cities, with multilingual communities developing their own hybrid dialects and forms of communication. While English may serve as a common language, the blending of native tongues will create linguistic diversity that reflects the multicultural nature of these habitats. This linguistic fusion will not only facilitate communication, but also deepen the cultural connections between residents. Festivals and celebrations in space will take on a new dimension, blending elements from various Earth-based traditions while incorporating the unique experiences of living in orbit. Imagine a festival where traditional dances are performed in zero gravity, or where music and art are inspired by the breathtaking views of Earth and the cosmos. These events will not only preserve cultural heritage but also create new traditions that are distinctly space-borne. The integration of diverse communities in orbital cities will also challenge and reshape societal norms. The close-knit nature of space habitats will require a heightened level of cooperation and understanding, fostering a culture of empathy and mutual respect. As people from different backgrounds learn to live and work together, they will develop shared values that transcend their Earth-bound differences, creating a more inclusive and harmonious society. However, this cultural blending will also come with its challenges. Differences in customs, beliefs, and practices may lead to misunderstandings or conflicts, requiring careful navigation and open dialogue. The success of orbital cities as cultural melting pots will depend on the ability of their inhabitants to embrace diversity while finding common ground. Ultimately, orbital cities will serve as a testament to humanity's ability to unite and thrive in the face of new frontiers. By bringing together people from every corner of the globe, these habitats will not only preserve Earth's cultural richness, but also create a new chapter in the story of human civilization, one that is defined by collaboration, innovation, and shared purpose. Next, we'll explore how space-based healthcare and medicine will adapt to meet the unique challenges of living in orbit. Now, let's turn our attention to the critical role of healthcare in the future of orbital cities. Space habitats will face unique medical challenges, from the effects of prolonged microgravity to the increased risk of radiation exposure, driving the development of advanced healthcare systems tailored to the realities of life beyond Earth. One of the cornerstones of space-based medicine will be telemedicine, allowing doctors on Earth to remotely diagnose and treat patients in orbit. Using high-definition imaging and real-time data transmission, medical professionals will be able to monitor astronauts' health and provide guidance for complex procedures, ensuring that even in the isolation of space, quality care is just a call away. Regenerative therapies will also play a pivotal role in addressing the physical toll of space living. Prolonged exposure to microgravity can lead to muscle atrophy, bone density loss, and other health issues. To combat these effects, scientists are exploring the use of stem cell therapies and tissue engineering to repair and regenerate damaged cells. Imagine a future where injuries that would take months to heal on Earth can be treated in weeks, thanks to breakthroughs in regenerative medicine that are accelerated by the unique conditions of space. Genetic engineering will further revolutionize healthcare in orbital cities. By modifying genes to enhance resistance to radiation or improve immune function, scientists could create a new generation of space-adapted humans. These advancements won't just benefit those living in space. They'll also have profound implications for medicine on Earth, offering new ways to treat diseases and improve overall health. Another key innovation will be the integration of artificial intelligence into healthcare systems. Artificial intelligence will assist in diagnosing illnesses, predicting health risks, and even managing treatment plans, ensuring that healthcare in space is both efficient and personalized. With limited resources and the need for precise care, artificial intelligence will be an indispensable tool for maintaining the well-being of orbital city residents. Space habitats will also pioneer advancements in mental health care, addressing the psychological challenges of living in confined environments far from home. Virtual reality therapies and immersive environments will help alleviate feelings of isolation, while counseling services tailored to the unique stresses of space living will provide essential support. As we look to the future, it's clear that space-based healthcare will not only meet the challenges of living beyond Earth, but also drive innovation that benefits humanity as a whole. From telemedicine to genetic engineering, the advancements made in orbital cities will transform how we approach health and medicine, both in space and on our home planet. Next, we'll explore how orbital cities will serve as testbeds for cutting-edge technologies before they're implemented on Earth. Now, let's shift our focus to the role of orbital cities as pioneers of innovation. These futuristic habitats will act as testbeds for cutting-edge technologies, providing a unique environment to refine and perfect advancements before they're brought back to Earth. One of the most exciting areas of testing will be energy systems. Space habitats powered by solar satellites will experiment with highly efficient energy capture and storage methods, offering insights that could revolutionize renewable energy on our planet. Materials science will also thrive in the microgravity of space. Researchers will develop stronger, lighter, and more durable materials that could transform industries like construction, transportation, and manufacturing. Picture a future where materials tested in space lead to safer, more efficient vehicles or buildings that can withstand extreme conditions. Artificial intelligence will play a central role in these experiments. In space, where resources are limited and precision is critical, artificial intelligence will optimize systems, manage experiments, and analyze data in real time. The lessons learned from its use in orbital cities will improve its applications on Earth, enhancing everything from healthcare to logistics. By serving as laboratories for innovation, orbital cities will not only push the boundaries of technology, but also bring tangible benefits to life on Earth. Next, we'll explore how virtual reality will integrate into daily life in space, offering new ways to work, learn, and relax. Turning our attention to the ways technology will shape daily experiences in space, let's dive into the transformative role of virtual reality. In orbital cities, virtual reality will become a cornerstone of life, seamlessly integrating into work, education, and leisure. Imagine conducting virtual meetings with colleagues on Earth, exploring distant planets through immersive educational programs, or relaxing in a digital beachside paradise, all from the confines of a space habitat. One of the most significant benefits of virtual reality will be its ability to combat isolation. Living far from Earth can feel lonely, but virtual reality will bridge the gap, allowing residents to connect with loved ones, attend events, and even explore familiar settings back home. This technology will create a sense of presence and connection that helps maintain mental well-being in the unique environment of space. Beyond social interaction, virtual reality will also enhance productivity and creativity. Workers in orbital cities could use virtual simulations to design complex structures or troubleshoot equipment, while students might engage in hands-on learning experiences that aren't possible in microgravity. Leisure activities will take on new dimensions, with residents enjoying immersive games, virtual travel, or even artistic pursuits that push the boundaries of imagination. As virtual reality becomes a daily staple, it will redefine what it means to live and thrive in space. Up next, we'll examine how orbital cities will tackle the challenge of waste management, ensuring sustainability in these futuristic environments. Now, let's explore a critical aspect of life in orbital cities: waste management. In space habitats, advanced waste management systems will play a vital role in ensuring sustainability and reducing environmental impact. Unlike on Earth, where waste can be stored or processed with relative ease, space environments demand highly efficient and innovative solutions to handle waste without compromising the delicate balance of closed-loop ecosystems. One of the key technologies will be advanced recycling systems that can break down waste into reusable materials. Everything from food scraps to packaging will be processed to extract valuable resources, minimizing the need to transport supplies from Earth. These systems will not only reduce waste but also support the self-sufficiency of orbital cities, making them more sustainable over the long term. Another groundbreaking approach will be the use of bioreactors to convert organic waste into energy or nutrient-rich materials. These bioreactors, powered by microbes, will transform waste into biofuels or fertilizers, contributing to the closed-loop systems that keep space habitats running. This process will ensure that nothing goes to waste, aligning with the principles of sustainability that are essential for life beyond Earth. The importance of these systems cannot be overstated. In the confined environment of a space habitat, waste management is not just a logistical challenge, it's a matter of survival. By developing and implementing these advanced technologies, orbital cities will set a new standard for sustainability, demonstrating how humanity can thrive in space while respecting the limitations of our environment. As we look ahead, these innovations will not only make space habitation possible, but also pave the way for a future where sustainability is at the core of every aspect of life, both on Earth and beyond. As we venture further into the future of orbital cities, another fascinating possibility emerges: their potential role in preserving Earth's biodiversity. Space habitats could serve as modern-day arks, providing safe havens for endangered species and protecting ecosystems that are under threat on Earth. In the controlled environments of orbital cities, scientists could replicate the conditions needed for these species to thrive, offering a lifeline for those on the brink of extinction. This approach would involve creating biomass within space habitats that mimic Earth's diverse ecosystems. From tropical rainforests to coral reefs, these biomass would not only house endangered species but also serve as living laboratories for studying their behavior and biology. By doing so, orbital cities could contribute to global conservation efforts, ensuring that the richness of Earth's biodiversity is preserved for future generations. However, this idea comes with significant ethical considerations. Questions about the moral implications of relocating species from their natural habitats to artificial environments must be addressed. Would this approach truly benefit the species, or would it disrupt their natural behaviors and evolutionary processes? Additionally, there's the issue of prioritization. How do we decide which species to save when resources are limited? These ethical dilemmas highlight the need for careful planning and international collaboration. Space habitats could offer a unique solution to one of Earth's most pressing challenges, but their role in conservation must be approached with thoughtfulness and respect for the natural world. As we continue to explore the possibilities of orbital cities, their potential to protect and preserve life, both human and non-human, remains a powerful reminder of our responsibility to the planet we call home. Looking ahead, the integration of biodiversity preservation into space habitat design could redefine humanity's relationship with nature, setting a new standard for sustainability and stewardship on a cosmic scale. Taking a step further into the future of orbital cities, let's explore their potential role as bustling centers for interplanetary trade. As humanity expands its presence beyond Earth, these space habitats could become crucial hubs for commerce, connecting our planet with colonies on the Moon, Mars, and beyond. With their strategic locations in orbit, these cities would offer a unique advantage for transporting goods across vast distances in space. The economic potential of interplanetary trade is immense. Imagine a future where resources mined from asteroids or manufactured in the microgravity of space are shipped to Earth, while Earth exports advanced technology, food, and other essential supplies to off-world colonies. Orbital cities could act as middlemen, streamlining these exchanges and fostering a thriving space economy. This could lead to entirely new industries, from space-based manufacturing to interplanetary logistics, creating jobs and opportunities that we can barely envision today. However, the logistics of transporting goods across space present significant challenges. Space travel is inherently costly and time-consuming, and moving bulky or fragile items between planets would require advanced spacecraft and infrastructure. Orbital cities could play a key role in overcoming these hurdles by serving as storage and distribution centers. They could house warehouses, repair facilities, and even assembly lines for spacecraft, ensuring that goods are transported efficiently and safely. Another factor to consider is the development of standardized systems for interplanetary trade. Just as international trade on Earth relies on agreements and regulations, space commerce would need frameworks to govern issues like tariffs, property rights, and safety standards. Orbital cities could become the venues where such agreements are negotiated, fostering international cooperation in the pursuit of a shared economic future. As we look ahead, the idea of space habitats as centers for interplanetary trade opens up exciting possibilities for economic growth and innovation. By bridging the gap between Earth and other celestial bodies, these cities could not only transform how we do business but also strengthen our connections as a spacefaring species. This vision of a thriving, interconnected space economy reminds us that the future of trade is not just global, it's interplanetary. Moving forward, let's turn our attention to the engineering marvels that will make space habitats resilient in the face of extreme environments. Living in space comes with unique challenges, from the absence of gravity to the constant threat of radiation and meteoroid impacts. Designing habitats that can withstand these harsh conditions will require groundbreaking innovations and creative problem-solving. One of the primary challenges is creating habitats that operate effectively in low-gravity or zero-gravity environments. On Earth, gravity plays a crucial role in everything from how we move to how our bodies function. In space, habitats will need to account for these differences, potentially incorporating rotating structures to simulate gravity or designing interiors that make movement and daily life easier for residents. Imagine living in a space where even the simplest tasks, like pouring a drink, require entirely new approaches. Radiation is another major concern. Unlike Earth, which is protected by its atmosphere and magnetic field, space exposes inhabitants to high levels of cosmic radiation. To address this, engineers are developing advanced shielding materials that can block harmful radiation while being lightweight and durable enough for space construction. These materials might include layers of specialized metals or even innovative composites that combine strength with flexibility. Meteoroid impacts pose yet another threat. Even tiny particles traveling at high speeds can cause significant damage to space habitats. To mitigate this risk, engineers are exploring designs that incorporate multiple protective layers, much like the armor on a spacecraft. These layers could absorb or deflect impacts, ensuring the safety of those inside. Additionally, habitats might be equipped with sensors and automated systems to detect and respond to potential threats in real time. The engineering challenges of creating habitats for extreme environments are immense, but so are the opportunities for innovation. By pushing the boundaries of what's possible, we can develop structures that not only protect residents but also enhance their quality of life in space. These habitats will be testaments to human ingenuity, showcasing our ability to adapt and thrive in even the most unforgiving conditions. As we continue to explore the cosmos, the lessons learned from designing these habitats will pave the way for a future where humanity can live and work safely beyond Earth. Now, let's consider how space habitats could play a pivotal role in addressing one of Earth's most pressing challenges: overpopulation. As our planet's population continues to grow, the strain on resources, infrastructure, and living space becomes increasingly severe. Orbital cities offer a potential solution by providing additional environments for human habitation beyond Earth. Imagine a future where millions or even billions of people could live and thrive in space, easing the burden on our planet. However, scaling up space habitation to accommodate such massive populations is no small feat. One of the primary challenges is the sheer scale of construction required. Building habitats for billions would demand vast amounts of materials, energy, and technological innovation. Transporting these materials from Earth would be costly and inefficient, so much of the construction would likely rely on in-space resources like asteroid mining and lunar materials. Three-dimensional printing could also play a crucial role, enabling the rapid assembly of structures directly in orbit. Another challenge is ensuring the sustainability of these habitats. Supporting billions of people would require highly efficient closed-loop ecosystems capable of recycling air, water, and waste without relying on constant resupply from Earth. Advanced agricultural systems such as vertical farming and genetically modified crops would need to be optimized for space to provide a steady food supply. Energy production would also need to be scaled up, likely through solar satellites or other renewable sources to ensure these habitats remain self-sufficient. Logistics and infrastructure present further hurdles. Transporting large numbers of people to and from these orbital cities would require a reliable and affordable system of space travel. Current spaceflight technologies are far from meeting this demand, but advancements in reusable rockets and commercial space travel could make this vision more feasible over time. Additionally, managing the social and political complexities of establishing new communities in space would require careful planning and international cooperation. Despite these challenges, the potential benefits are immense. By creating additional living space in orbit, humanity could reduce the pressure on Earth's ecosystems, preserving biodiversity and natural resources for future generations. Orbital cities could also serve as testbeds for new technologies and sustainable practices that could be applied back on Earth. While the road to realizing this vision is long, the role of space habitats in addressing overpopulation offers a glimpse into a future where humanity thrives both on and off our home planet. As we continue to innovate, the dream of expanding our horizons beyond Earth becomes more attainable, promising a brighter future for all. Turning our attention to the economic implications, orbital cities are poised to become more than just habitats. They'll serve as vital extensions of Earth's economy. Picture this: space-based manufacturing hubs leveraging microgravity to produce materials and products impossible to create on Earth. Think advanced alloys, ultra-pure semiconductors, and pharmaceutical breakthroughs industries that could revolutionize global markets. By tapping into the unique conditions of space, orbital cities could unlock entirely new sectors, driving innovation and economic growth here on Earth. Tourism is another area where space habitats could shine. As space travel becomes more accessible, orbital cities could become must-visit destinations, offering experiences like zero-gravity sports, Earth-gazing observatories, and even luxury accommodations with breathtaking views. This burgeoning space tourism industry wouldn't just generate revenue for orbital cities, it would also create jobs and stimulate technological advancements that ripple back to Earth. Additionally, the integration of space habitats into Earth's economy could reshape global trade. With the potential for asteroid mining and resource extraction in space, raw materials like rare metals could be transported back to Earth, reducing the strain on terrestrial resources. Meanwhile, Earth could supply orbital cities with goods and expertise, fostering a symbiotic relationship that benefits both. This interconnectedness would blur the lines between Earth and space economies, creating a new era of collaboration and prosperity. As we look to the future, the economic potential of orbital cities is vast and multifaceted. By seamlessly integrating space habitats into our global economy, humanity could unlock unprecedented opportunities for growth, innovation, and sustainability. The possibilities are limitless, and the journey is just beginning. Now, let's take a closer look at how space habitats might influence the very essence of who we are as a species. Living in the unique environment of space could have profound effects on human evolution, both physically and cognitively. In the microgravity of orbital cities, our bodies would adapt in ways that are still being studied, from changes in bone density and muscle mass to alterations in cardiovascular function. Over generations, these adaptations could become inherited traits, shaping a new kind of human better suited for life beyond Earth. Cognitively, the challenges and opportunities of living in space could also drive significant changes. The need to problem solve in an environment vastly different from Earth's could accelerate the development of advanced spatial awareness, creativity, and adaptability. Imagine future generations of spacefarers who are not only physically adapted to zero gravity, but also possess heightened cognitive abilities honed by the unique demands of orbital living. Moreover, the isolation and confined spaces of space habitats might lead to shifts in social and psychological behaviors. Communities in orbital cities could develop new ways of communicating, collaborating, and resolving conflicts, fostering a culture of resilience and innovation. Over time, these changes could influence the collective mindset of humanity, steering us toward a more collaborative and exploratory future. As we venture further into space, the possibility of humanity evolving into a spacefaring species becomes increasingly tangible. Space habitats could serve as the crucible for this transformation, shaping not just our bodies and minds but also our identities as a species. The journey to becoming a spacefaring civilization is not just about technology, it's about how we as humans adapt, grow, and evolve to thrive in the vastness of the cosmos. Shifting our perspective, let's consider the deeper meaning behind humanity's quest to build space habitats. Orbital cities are not just feats of engineering, they are powerful symbols of human ingenuity and collaboration. These structures represent our ability to tackle challenges that once seemed insurmountable, from surviving in the vacuum of space to creating self-sustaining ecosystems. Each milestone in space habitation is a testament to the collective effort of scientists, engineers, and dreamers who dare to push the boundaries of what's possible. Culturally, space habitats reflect our shared aspirations and curiosity. They embody the human desire to explore, innovate, and create a better future, not just for ourselves but for generations to come. Orbital cities could become beacons of hope, showcasing what humanity can achieve when we work together toward a common goal. From multinational space agencies to private companies and individual contributors, the story of space habitation is a story of unity in diversity. Philosophically, the idea of living beyond Earth challenges us to rethink our place in the universe. Space habitats force us to confront questions about identity, purpose, and the nature of humanity itself. Are we Earth-bound creatures, or are we destined to become a multiplanetary species? Orbital cities invite us to imagine a future where our horizons are limitless, and our potential is defined not by our limitations but by our collective imagination and determination. In the grand tapestry of human history, space habitats stand as a bold reminder of what we can accomplish when we dare to dream big and work together. They are a symbol of resilience, innovation, and the unyielding spirit of exploration that defines us as a species. As we look to the stars, these habitats remind us that the greatest frontier we must conquer is not just outer space, it is our ability to unite, adapt, and thrive in the face of the unknown. As we bring this exploration of the future of space habitats and orbital cities to a close, let's take a moment to reflect on the incredible possibilities we've uncovered. From modular habitats that evolve with our needs to self-sustaining ecosystems that mimic Earth's balance, these predictions paint a vivid picture of what life beyond our planet could look like. We've envisioned cities buzzing with economic activity, powered by limitless solar energy and managed by advanced artificial intelligence. We've imagined spaces where humanity thrives, not just survives, fostering innovation, culture, and even new perspectives on our place in the universe. These 30 predictions aren't just isolated ideas, they're interconnected visions of a future where humanity expands its horizons, both literally and figuratively. Whether it's the role of these habitats in preserving Earth's biodiversity, their potential to serve as hubs for deep space exploration, or their ability to inspire unity and collaboration across borders, each prediction contributes to a larger narrative of progress and possibility. What's truly remarkable is that many of these advancements are already within our reach, thanks to the relentless efforts of scientists, engineers, and visionaries around the world. The journey to building orbital cities isn't just about overcoming technical challenges, it's about embracing a mindset of curiosity, creativity, and collaboration. It's about daring to imagine a future where the stars are not just points of light in the sky, but destinations waiting to be explored. As we look ahead, we invite you to consider your place in this extraordinary vision. What role might you play in shaping the future of space habitats? How might you contribute to a world where humanity thrives not just on Earth but among the stars? The possibilities are as limitless as the cosmos itself, and the story of space habitation is one that we are all writing together. So stay curious, dream boldly, and remember, the future of space is not just a distant fantasy. It's a reality we're building, one prediction, one innovation, and one step at a time. If you're as excited about this journey as we are, don't forget to subscribe, hit the notification bell, and join us as we continue to explore the wonders of the universe. The stars are calling. What will your answer be?